Alright, so the microphone's on and I'm now recording. So first, in order to go about finding the rational roots, you have to use the rational root theorem. So basically you have to take all the positive and negative factors of this right here, of the constant. So then you can have plus or minus 1, 2, 3, and 6. And that has to be divided by the factors of the leading coefficient, which in this case is just 1. So it's plus or minus 1. So that means that the potential rational roots that we might be able to have are positive or negative 1, 2, 3, and 6. So we just have to, we just basically have to now just test it out using like a synthetic division. So, and you just have to keep going until you find a root. So let's set it up 1, negative 1, negative 5, negative 1, and negative 6. So since this is 1, we're going to be testing x minus 1 here, because 1 minus 1 equals 0. So let's just bring this down. 1 times 1 is 1, negative 1 plus 1 is 0. 1 times 0 is 0, so this would be negative 5. Negative 5 times 1 is negative 5. Negative 1 plus negative 5 is negative 6. Negative 6 plus 1 is negative 6. Negative 6 plus negative 6 is negative 12. So we know that is not a possible root, because it has to end with a remainder of 0. Now let's try x plus 1, which would end up having us put negative 1 over here. So let's do 1. Hold up, my Apple Pencil is out of battery. Let me just wait a few seconds. Alright, that should be good enough. Yeah, it works. Okay, so we have to bring this down. 1 times negative 1 is negative 1. Negative 1 plus negative 1 is negative 2. This would be 2, negative 3, 3. Negative 3 is 2, negative 2. This would give us a remainder of negative 8, so that does not work either. We just have to keep testing it like this. Now let's try x minus 2. Alright, so 2, negative 1, 2, negative 3. Okay, so none of this one does not work either, because we don't end up with a remainder of 0. Now if we try negative 2, we have like this, 6, 1. So still no remainder of 0. So let's just keep trying until we get something that has a remainder of 0. Right, and it appears that this is our first root that we managed to find a remainder of 0. So this would be since this is 3 and this is the 0 that we're looking at, this would be x minus 3. This is one of the factors of this. So now that we properly divided this and found out that this is a potential root, now we can use this shortened equation, this shortened polynomial instead, which would be x cubed plus 2x squared plus x plus 2. And at this point, as you can see, you can just factor this by grouping. So we can just do x squared, and then this would be x plus 2, as well as here this would just be 1, and then x plus 2. So as you can see, our factors are going to be x minus 3, x plus 2, and x squared plus 1. And x squared plus 1 can actually be factored further, not into real roots, but we can find imaginary roots out of this one. So what we have to do here is since here we have x squared plus 1, Now what we have to do, we have to use the quadratic formula. So we could do negative b, and actually let's just write this out like this. And since there's no b value, let's just leave this blank. So let's just do negative 0, I guess. Plus or minus the square root of, whoops, the Apple Pencil died again. Let me wait for it to charge back up. Alright, it should be better now. Okay, so plus the square root of 0 squared, because we have a value of 0 as the b value, minus 4 times a times c. So this would be 1 and then 1. All over 2a, so that would just be 2. So here we would end up getting, the square root of negative 4 over 2. And as you know, the square root of negative 1 is I. So that means the square root of negative 4 would be 2i, because because the square root of 4 is 2, and then I is the square root of negative 1. So you would end up getting 2i. And since you have that over 2, it would just end up equaling I. So that means you could have plus or minus I for this one. Plus or minus I. And it appears we also have to graph this. So since it appears that we have to, so x minus 3, that would be right here. And since it is to the power of 1, we know that it's going to be going through. And since you can see we have x to the 4th, we can see that that means that this is going to be a polynomial with an end behavior of x approaches, x approaches in both in positive and negative infinity, y or f of x would approach positive infinity. So let's just Alright, whoops, so now my mic is on, you should be able to hear me. So since this is a polynomial that doesn't really have extrema that are rational numbers, and they appear to be irrational numbers with no terminating digits, I decided to graph it on my calculator. And obviously, since the roots here, the real roots are x equals negative 2 and x equals 3 right here. So you can obviously, it would have to cross the x-axis right here and right here. And since we know that the end behavior is going to be x approaches y approaches infinity on both sides, as x approaches both infinity and negative infinity, we can create end behavior arrows like this. And since this is not really going to be perfectly properly to scale, but let me just make this better. It's actually gonna look something more like this. But basically how it's going to go is, according to how I've graphed it on my calculator, the absolute lowest extrema is seems to be roughly at negative 20, so it's not even going to really be on this graph. So it's just gonna go through here, it's just gonna go all the way down like this. So I'm just going to not put anything. And then it comes back and it go at roughly -6. So 1, 2, 3, 4, 5, 6. At roughly -6 on the y-axis, it goes back down. It goes back down. And then at roughly x is equal to -1, so right about here, it changes and it looks something like this. So let's change that. Let's make it like that. So that's roughly how this graph ends up looking like. Let me just make it so that this looks like not a straight vertical line like that. That's better. Alright, so basically the domain here, as you can see, this extends out here and this extends out here. So our domain is going to be all real numbers. Our range is going to be, as I've said, the lowest absolute extrema is at roughly at -20. To be exact, it's at -20.019, rounded to the thousandth place. So the range is going to be -20.019 to positive infinity. And then the end behavior is going to be as x approaches both positive and negative infinity. Y approaches, it's better to say f of x. F of x approaches infinity. Now our extrema, we have an absolute extrema at x I'll just give the entire coordinates. That roughly 2.037 and -20.019. And then we have not an absolute extrema, but an area, point where the sign changes, and that is roughly -0.010, -0.104 and -5.949. And then we have one more local extrema at roughly -1.184 and -8.2. So our increasing intervals here are going to be obviously this entire thing right here. Let me write this in red. This entire thing over here, as well as this small area right here. So our increasing interval is going to be from -8.2 to -5.949, as well as from I'm gonna use the x coordinates, not the y coordinates. That's probably a better idea. So if you use the x coordinates, it would be -1.184 to -0.104, roughly. And keep in mind, this is all rounded to the thousandth place, so this is not perfectly exact. And then obviously you have 2.037, then to infinity. In the decreasing interval, it's going to be this whole thing right here, as well as this little bit right here. So the first one would be from -infinity all the way to this point right here, which is -1.184. as well as for this smaller bit right here, this goes from roughly negative 0.104 to 2.037. Alright, and let me just erase this. And we have to verify the roots by multiplication. So our let me just write the actual roots here. X is equal to 3, x is equal to negative 2. And then the roots are going, so let's just multiply all three of these things together. So x minus 3 times x plus 2, yeah, x plus 2. This would be x squared, then plus 2x minus 3x minus 6. So then this would equal x squared plus, this would be minus x minus 6. And then we have to multiply this times x squared plus 1. So x squared minus x minus 6 times x squared plus 1. This would give us x to the 4th, and then plus x squared minus x cubed minus x minus 6x squared minus 6. So now if you combine like terms and sort this whole thing out, you'll get x to the 4th minus x cubed minus 5x squared minus x minus 6. If you compare this back to our original expression we have here, you'll see that they indeed do match up.